Welcome to qnawire.
Okay, so we know that the car is going along with some sort of kinetic energy, some specific kinetic energy, and that is given by our normal equation for kinetic energy, 1/2 mv squared, right? And then we also know that we have the potential energy of the spring at every single point um, in x, its compression distance. So that potential energy is U equals 1/2. So that's a 1 up there. 1/2 kx squared. Cool. Okay, so the key here is that as the car compresses the spring, more and more of its kinetic energy goes into the potential energy of the spring. So we can actually equate um, the E and the mu here. We can actually say those two are equal. And then we can do that, and canceling the 1/2s, we come out with mv squared is equal to kx squared. And then we just have to solve for k. And we see that k is equal to mv squared over x squared. And then you can substitute in the numbers that were given in the problem. So 12,000 kilograms times 0.65 meters per second squared over 0.09 meters squared. Yeah, and then that'll give you your value for k. And actually, this formula is valid for really any type of spring you want to design, given just the mass of the car and the velocity of it. So yeah, pretty useful.